All right, this is 11.5, finally the end of Unit 11, the margin of error. Margin of error is a big deal, and I wrote the text out here to try to speed things up, but it's awesome. It's impossible to basically survey an entire population. So you sample instead. Now, margin of error is to some degree a statement of how close you feel the sample's results are to what the true result is. And a margin of error is a number, it's plus or minus something. That's all it is. Maybe you guys have paid attention to presidential polls or election polls. They always include a plus or minus statement. That's because that was the margin of error of the poll. But anyways, here's this. Try and copy some of that down. I might just leave that empty to speed up class, because if kids have to write, it's going to take a while, isn't it? It is. Yeah. So anyways, speed that up. Samples of students' benchmark are analyzed to have a mean of 62%, a standard deviation of 9.2%. A 95% confidence interval is constructed with a margin of error of plus or minus 3.7. How many students were in the sample? Now, it's a 95% confidence interval, so the margin of error is simply 2 sigma over square root of n. Of course, we have the plus or minus, but that's not a big deal. We're just going to use 3.7. All we're going to do is we're going to plug in and we're going to do algebra, bro, because we are in algebra. Standard deviation is known to be 9.2, so twice 9.2. And the question was how many kids n were in the sample, so that's the unknown. Let me see here. The opposite of division is multiplication. So I'm going to have 3.7 square roots of n on the left, twice 9.2 being 18.4. Divide out my 3.7, and I don't care what 18.4 over 3.7 is, because I'm just thinking about the next move. And the last move, the opposite of square rooting, has always been squaring. So now I'm going to go to my trusty little TI-84, and I'm going to see what 18.4 over 3.7 all squared is. And that's going to be, when I round accordingly, or I round appropriately, let me say, the number of people that were in the sample. And it's going to be close to 25. It's going to be so close to 25, I'm going to say 25. It isn't about, if there were 25 people. 24 wouldn't have done it. You wouldn't have got 3.7 as your margin of error. Had to have been 25. Moving forward with our lives. College Board recently reported the mean score on the SAT mathematics exam is 508, with a standard deviation of 121. Washington High believes that its seniors score considerably higher than national average, so school randomly sampled scores from 200 students, 200 seniors finding a mean of 550. Is Washington High correct in its belief? All right, so we're going to have to use the standard deviation from the national poll here, which is fine, which is probably the right way to do it. Well, here's the deal. And we haven't defined it yet. And sometimes your textbook lays things out so funny. An unusual event is any event that is more than 2 standard deviations from the mean. That's one way of doing it. There's also the less than 5% chance of happening, but more than 2 standard deviations of the mean. And the 95% confidence interval is 2 sigma, right? 2 standard deviations of the mean. So an event is unusual if it lies outside of a 95% confidence interval. So we're going to construct a confidence interval for Washington High. And we're going to go with it. Now, the first thing we're going to need is we're going to need our margin of error. The margin of error is going to be 2 sigma to 121, sitting pretty over the square root of the sample size, 200. It's going to give me 242 over root 200, but who cares about that? We're just going to go push some buttons. 2 121s sitting pretty over the root of 200. We'll say that's roughly 17.1, okay? Yeah, let's do two digits, 17.11. Now, the 95% confidence interval is simply X bar take away the margin of error, and then through X bar plus the margin of error. Now we'll just do some math, all right? So X bar here for our sample was 550. We're going to have 550 minus 17.11 through 550 plus 17.11. So 550 take away 17, we're looking at 533, 529 because of the decimal, 0.89. Then we can add 567.11. So, are Washington High's events unusual? Yes, they are. Because the national average does not lie in Washington High's 95% confidence interval, the event is unusual. They are significantly above average. If that confidence interval contained the national average, then there'd be nothing special about Washington High whatsoever. All right, I will be right back. How long has this video been so far? 7. A SAMP-A, apparently, a 40 DHS students' GPA yields a 99.7% confidence interval for the mean of all DHS students to be 2.1 through 3.7. Determine the sample's mean. This is actually surprisingly easy. The sample's mean lies in the middle of 2.1 and 3.7. That's how it works. So to find the middle of something, you add the two things together, and then you divide it by 2. That's all you do. It ain't rocket science, but for some it is, I reckon. So anyways, what's that going to give me? 5.8 that we cut in half, 2.9. Seems legit. Now, determine the sample's standard deviation. Well, also while I'm at here, because I know that the sample's mean is 2.9, think about how we form a confidence interval. We take X bar and we take away the margin of error through X bar plus the margin of error. I also know that the margin of error, if the middle is 2.9, the margin of error is 8/10 because 2.9 plus 8/10 is 3.7. Now, how can I do that? How can I use that to determine the sample standard deviation? First off, this is a 99.7% confidence interval. So the margin of error would be 3 sigma over the square root of n. Now, I know that the margin of error is 8/10, and it would equal to 3 sigma, which is unknown at this point in time, sitting over the square root of 40. All right, first step, multiply both sides by root 40. 8 roots of 40 is 3 sigma, and then we're just going to divide by 3, and that's going to be our standard deviation. So we got 8 roots of 40. That is going to sit pretty over a 3, and there's sigma, which is about 16.87. Something seems wrong about that. Oh, because it's 0.8 root 40. That's better. 1.69. All right, create a 95% confidence interval for the mean GPA of DHS. Okay, so the 95% confidence interval has a margin of error of 2 sigma over root n. Okay, so it's going to be twice 1.69. Sitting pretty over the square root of 40. So let's see what that ends up being. 2 times 1.69, sitting pretty over root 40. Is about 0.53. You'll notice as the confidence intervals get smaller and smaller, so does the range of values. It's kind of how they work. It's just how they work. It's interesting. But anyways, the margin of error here is only 0.53. So the confidence interval here is going to be our 2.9 minus 0.53 through 2.9 plus 0.53. 2.9 minus 53 hundredths, or 2 and 9/10 minus 53 hundredths, however you want to say it, is going to be 2 and 37 hundredths. 2.37 on one side, and then we can add, it's going to give us 3.43 on the right. You'll see again that the range has gotten smaller because you're not as confident, that's why. And this will be the smallest of them all. A 68% confidence interval would be a single standard deviation over the root of n. So it's going to be this 1.69 sitting pretty over root 40, which is going to be an even smaller number. And it's about 0.27. All right. Now, let's take our middle of 2.9, take away 0.27, 2 point what? 63. Through, we add 3.17. A student has a GPA of 3.54. Is this considered unusual for a DHS student? Now remember that an unusual event is an event that lies outside of 2 standard deviations or lies outside of a 95% confidence interval. So that's the question. Does 3.54 lie outside of the 95% confidence interval? So here's the 95% confidence interval. It goes for anywhere from 2.37 to 3.43. So yes, it is unusual. Yes. Because it doesn't lie in there. They're an unusual event at Dresden High School, apparently. It's kind of sad, actually. All right, 12 minutes. All right, of course, we've already talked about the definition of the unusual event. I'm going to rearrange these notes a little bit. Be right back. Coach K believes that we have an unusually high chronically absentee rate. Chronically absent student misses 10 or more days of school, and the state yells at us for anything over 10%. I have several of you in fifth period that are chronically absent. That state average, which is a parameter for being chronically late, is 11.2%. Coach K samples 45 students and finds that 19.8% of them are chronically absent, which is a statistic because it came from a sample with a standard deviation of 3.8%. Construct a 95% confidence interval for the mean DHS absentee rate. And oh, the number of you that are going to say IDK on this because you just don't want to write down a formula. Like, it's apparently too much for your brains. A 95% confidence interval has a margin of error of plus or minus 2 sigma sitting pretty over root n. So let's see here. There's sigma 3.8. It's a sample one, but that's fine. It's just the one we have to use. 45 students, root 45. 1.13. There you go. It's about 1.13. Easy peasy lemon squeezy. Now to actually create the interval, and I want the interval for the DHS one, not the state. This is my sample or my statistic, my sample parameter, 19.8. On one side, I'm going to take away the margin of error. And on the other side, I'm going to add the margin of error. That's all I have to do. 19.8, take away 1.13 is what? 18.67, seems legit. And then 19.3 plus 1.13 should be 20.43. Now, compare our confidence interval to that of the average of 11.2%. Does DHS have a significantly higher rate of chronic absenteeism than the rest of the state? Yes, because our true mean is somewhere between 18.67 and 20.43. Okay? The state mean does not lie in that interval. Easy peasy lemon squeezy. Awesome sauce. So, we got one more to do. And it's a calculator problem. So why don't you put this right back in your calculator? I'm going to pause for a minute and do the same thing. But put this in your calculator. Well, I actually don't know how to put that in your calculator. Anyway, I still need to pause. Anyways. All right. So you pull up your TI-84. You are going to have to use what's called class midpoints. That's going to bug you. Anyways, we're going to stat. We're going to edit. Halfway between 57 and 59 is 58. And not all of y'all have been able to figure this out yet. Halfway between 60 and 62 is 61. I have a typo. Halfway between 63 and 65 is 64. Halfway between 66 and 68 is 67. Halfway between 69 and 71 is 70. And halfway between 72 and 74 is 73. All right. Then you got your frequency count. It goes 2, 3, 4, 6, 2, 1. And then we're going to quit. Second quit. We're going to go to stat. We're going to go to calc. We're going to go to 1var statistics. The frequency list is L2, so second L2. And we're going to hit calculate. And there's everything I need to know. Now, this is sample data, so this is going to be a little different. Everything else we've just done, we've assumed it was population. We're going to use S of X, not sigma. So S of X is about 4.12. We're still going to use X bar for the mean. So we got 65 and then 4.12. So X bar is 65 and S of X is 4.12. All right, construct a 95% confidence interval that contains the true mean of all DHS students. Again, so for the fourth time today, we're going to find the margin of error. It's 2 sigmas, 4.12, sitting pretty over the square root of the sample size. So, we got 2 and 3 is 5, 9, 15, 18? Check this out too. N is 18. Look at that. And there you go, and we push some buttons. All right, so let's see what happens. We push some buttons. Twice of 4.12. That is sitting pretty over the root of 18. It's about 1.94. All right, so our 95% confidence interval that contains the true mean of all DHS students. Now, let's find out. Let's see here, where was I? Oh yeah. We have our 65, because that's the mean. Remember, this is inches, all right? We're going to take away 1.94. Awesome. And on the other side, we have 65 plus 1.94. They seem like tall numbers. 65 is 5'5". I guess that's probably about right. All right, so 65 minus 1.94 is 63.06. And then 65 plus 1.94, 66.94. There you go. You are 95% confidence that the true mean of DHS lies in that sample. Now, part 3 is not worded right. That needs to be changed up. That's what I was sitting there thinking about. If you'd acted like I was doing something else, I was. I was thinking about this question. A sample of freshmen's is found to have a height. Let me say this. A sample of a different sample. mm, So another sample of DHS students is found to have a mean of 57 inches. Is this unusual? Well, the answer is yes. Actually, I don't even like that question. I know. Say the state average student height is, of course, we're dealing with height with kids in high school, 64 inches. Is the DHS average height unusual? No, since the DHS confidence interval contains 64 inches, comma, DHS is normal. There we go. That's the question you like. Anyways, there's your confidence intervals. So I think I've figured out how to shave about 5 minutes off this lesson as I walked you through it this morning. So thank you for paying attention.